Okay, so I want to talk about graphing in slope-intercept form. All right, and this is I absolutely love graphing because sometimes I can graph my way to a solution a lot faster than to solve it mathematically. All right, and so by now you're all familiar with y equals mx plus b. All right, and b represents the y-intercept, and b represents the y-intercept. So we always begin our graphing on this line. B represents the y-intercept. And M represents how we move, okay? M is our rise over run, all right? So M can be our rise over run. Many of you may remember that. Or perhaps you were told it was a fall over a run, okay? Pretty much depending on how it is. So B is typically where we begin, and then M is how we move, whether we are rising in a positive or if it's negative, we're falling. So we're going to talk about that. But before we do that, I want to show you a couple different types of slopes, okay, to make sure you understand a couple different types of slopes. Okay, so there are 4 types of slopes I want to talk to you about that you'll find in your student journal. And I just want to make sure you understand what they are, all right? So one of them is when our line is going up in this direction, all right? Make sure you understand that this is a positive slope, all right? That is a positive slope, all right? If the line is going down in this direction, we call that a negative slope. All right. And there's another way, aside from visually looking at them, is when you have your equation y equals mx plus b, the number here will be a positive number. But when you have a negative slope, you have y equal, and you'll have a negative number, x plus b. All right. So those are 2 very easy ones. But then we also have when our line just simply goes horizontal. All right. So that it has what we call a zero slope. All right. That is a zero slope. All right. And sometimes, as you saw earlier, you have a vertical line that just simply goes straight up and down. All right. And this is called an undefined. And it's going to be very important that when you see these, you can tell what kind of slope they are. Positive, negative, zero, or undefined. All right, so those are 4 basic slopes. So now I want to talk about how do we find slope. All right, let's talk about how do we find the slope. Okay, so let's talk about how do we find the slope. So there's multiple ways that we can find the slope of the line. Okay, there is a formula for finding slope, and it is m. It would help if I had my pen together here. All right, so our formula for finding slope is m equals y2 minus y1 over x2 minus x1. All right, so there's a numeric way to find a slope, and then sometimes you can count the slope. All right, so in your textbook they give you some examples of some slopes, I believe on page 83. All right, so if you look at page 83, all right, you have a line that essentially goes straight up and down here. And you have a point here at 3, 4. And you have one at 3, negative 4. All right. So those are your two. So if I were to look at this just visually by looking at this, if you recall earlier, we talked about the 4 different types of slope. So we had positive slope that went up. That's obviously not positive. We had a negative slope that went down. Okay. And we had one that went vertically. And we had one that went horizontally. All right. So I'm going to pause it, go back for a minute. I want you to turn back to the other page, and I want you to tell me, which of these slopes is it? Is it a positive slope? Is this a negative slope? Is this a zero slope, or is this an undefined slope? All right. So if you went back and looked at your previous notes, you would have selected and said, hey, these two look alike. Therefore, this is what we call an undefined slope. This is undefined. All right. And that's all your textbook is asking you. Look at it and then describe the slope of the line. All right. They also ask you to find the slope. All right. So in a undefined slope, all right, how do you find an undefined slope? How would that look mathematically if we found an undefined slope? All right. All right, so let's look at how we would set this up. All right. If we're going to go y2 minus y1. All right. So I'm going to say negative 4 minus 4 over 3 minus 3. Okay. And 2 negative 4s, so negative 8. All right. And 3 minus 3 is 0. Well, you may look at that and say, hey, what is 8 divided by 0? All right. This is undefined. All right. So if we set this up and we have a 0 in the denominator, we call that an undefined slope. All right. Example number 2, you have a graph that looks very similar to this with the line going through negative 1 and negative 4. The coordinate point at that location, the coordinate point at 3, 4. All right. So again, mathematically, the formula for finding the slope is m equals y2 minus y1 x2 minus x1. All right. So if I'm going from left to right, this is the first x and y coordinate I come to. This is the second x and y coordinate. Right. So I'm going to start with the second one. So y2 is 4. And the minus sign is built right into the equation. And my x is 3. All right. This is negative 4. All right. And I'm putting it in parentheses because that's going to make a big difference when I go to solve this. All right. And this is negative 1. So the minus sign is built in there. And then I'm going to put my negative 1. Otherwise, we'll come up with a totally different answer. All right. So negative times a negative. This is the same as saying what is 4 plus 4 over 3 plus 1. Right? Because those two negatives cancel each other out. And we end up with 8 over 4, okay, or 2. All right. And because we're counting slope, we're going to still call it 2 over 1. Right? So let's count that off and let's see what happens. All right. I can do the 8 over 4 and then see if it comes out to be the right, although this is a simplified version. But let's start with counting this up. All right, if our math is correct, starting at by 1, I'm going to go up 8 and over 4. All right, so let's see. Okay, if this in fact goes up 8 and over 4. All right, so let's go 1, 2, 3, 4, 5, 6, 7, 8. So I've come up 8, and now if my math is right, I'll go over 4. 1, 2, 3. Oh, I skipped 1. All right, let's count that off again. So we're here. 1, 2, 3, 4. There we are. Okay. Be very careful when you're counting that you don't skip. A lot of people tend to skip right around when they get to the axis. All right. So that's how I can find the slope of the line numerically, and then I can check it by visually just counting. It is a positive slope, so this should be a positive number. All right. Okay. Another way that you can find the slope is through a table. All right. So I'm going to do an XY table like so. XY. All right. And I believe the example your book has 1, 2, 3, 4. And for Y we have -2, -2, -2, -2. All right. And so what we know that X is not repeating, so yes, this is going to be a function. And Y seems to always be at what location? Y seems to always be at -2. All right. So if I were to graph that, here's my X and Y axis. 1, 2, 3, 4. 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. If I were to graph this line here, you would see that Y is always at -2. There's my line. All right. And when we have a line going straight across like that, if you recall that, we said that this is a horizontal line or a zero slope. All right. Yes, it is a zero slope. All right. You have another example there as well in your book, so let's look at that one. See how it pans out. X and Y, -3, -1, 1, and 3. And your Y coordinates are 11, 3, -5, and -13. All right. So there's quite a few different ways. One of the fastest ways that I found for students to actually find a slope is just to say, hey, what is the difference between -3 and -1? What is happening here? All right, so we say it's +2. And here we have +2. And once again, I have a +2. All right. But something different is happening here. The numbers are getting smaller. All right. The numbers are getting small. So what do I have? A -8. Change between these two is a -8. And again, a -8. So if I were to put that in slope-intercept form, which M equals a change in Y over the change in x. And I usually put a change in x and change in y. And what I have is have a negative 8 over 2. All right. So my slope is a negative 8 over 2, or I can simplify, since in this example they're just asking to find the slope of the line, I can say it is a negative 4. The slope is negative 4. All right. So we've talked about how to find the slope of a line by looking at a graph. We've talked about looking at a table. Now I want to talk about finding the slope by just looking at the equation. All right, so let me clear this and we'll start with a fresh sheet of paper. Okay, in our last example, I just want to find two things. I want to find the slope, and I want to find the x-intercept. All right, so my goal is to find, I'm just going to write it down here, is my slope and the y-intercept. All right, and if you remember earlier, when we were talking about slope and y-intercept, we said that y equals mx plus b, and we pointed out that the slope is represented by the number in front of the x, and the y-intercept is represented by b. All right. So let's start with the one in the middle. It's very easy. It's already set up in y equals mx plus b format, equals mx plus b format. So it's very easy for me to just identify the parts. Okay, in this particular one, my slope equals negative 3/4, and my y-intercept, which is called b, is equal to positive 2. Very simple. Nothing else for me to do other than just simply eyeballing it and identifying the slope and the y-intercept. All right. So then I come here. This is I see my x, so it appears to be y equal mx, but they left off b. And so a lot of times I go back and forth with students and they say, but there is no b. So when we call that there is no b, all right, and you say there's nothing there, what's another word for nothing? 0. So I can very easily say, hey, m equals 5, and b, because nothing there, is 0. All right, nothing is there, so b is 0. All right. All right. And then our last one here is like, that looks like I can put it in standard form. Okay, and it can. And you might recognize it already, like, okay, well, that looks like that's going to be m because it's with the x. This is all by itself, so it must be b. However, it needs to be simplified before we can do anything else because I have a 4 here in front of the y. So I'm going to need to simplify this before I can give a final answer. All right, so let's rearrange everything. All right, the 6x needs to be on the other side, so I'm going to move the 6x to both sides by subtracting 6x. All right, and then I can actually write it now in somewhat of a slope-intercept form by saying 4y equals, and I'm going to go ahead and put the negative 6x first because in our equation the slope and the x comes first, plus 24. All right, now my last step, so that I essentially am solving y by itself, is I'm going to divide everything by 4. And this is why I tell you fractions never go away. They just stay. We're not going to simplify this fraction. We're going to simplify, but we're not going to convert it to decimals. Equals negative 6 over 4x plus, and 24 divided by 4 is 6. Now I can simplify the slope, and I have y equals negative 3 over 2x plus 6. Now it's very easy for me to pick out my slope and my y-intercept. All right. So in this case, m equals -3 over 2 and b equals 6. So there you are. Let's get started with today's homework, and I'll gladly answer any questions you might have in class.